Hey everybody, Lars here. This is the second video for Big Bad Unit 5, and in this video we're going to go over a couple of different facets of object orientation that come along for the ride when we design our programs this way, but they're pretty important, and actually they're two of the most important reasons why we bother with object orientation in the first place. But the first thing I'm going to do is we are going to bring up some code that I already wrote. It has always been, let me set this up here. It has always been my opinion that when you first start object orientation and you first start doing classes, that the best way to learn is to see a ton of examples. So you'll notice in your slides we did the die class, and then a little bit later on we did the abstract student class. The last video I gave you, we did the checking account class. Now today we're doing something completely different. We're going to do an animal class. I want people to see a lot of examples so that you can extract out what's the same about all those things, and then you can understand what classes are really about. The first thing I'm going to do here, let's see, I will call the variable myAnimal, and I will assign it animal, and I will say that the animal is a dog named Fido, and that the dog is 30 pounds. And then I will print myAnimal dot get name, and then my animal dot get weight. Oh, all right. Does that look like it's going to be correct? I think it is. Okay, my animal's that. My animal's that. Okay, so let's run it. Beautiful. And now we can talk about what's going on, trace through this code, and get comfortable with classes in OOP again before we move on to the other stuff, okay? So what's going on here? We run this program, and you can see up here on the top you have comments, so you ignore them. Then you have a class. A class, kind of like a function, gets stored in memory and sits there waiting to be used. So we're going to put all of that in memory. Another comment, the first thing we actually run in this program is the second to last line, where I set up a variable. It's called myAnimal, and it's assigned an object. And that object is created with the animal class, which we have in memory. And I'm given two parameters to the constructor. One is the string Fido, and one is the integer 30. Okay? So, where's the animal class? I come up here. Does it have a constructor? Yes. Dunder init dunder. Self, as we talked about at the end of the last video, is kind of the location of the actual object. It refers to the actual object. Name, it's going to be the string Fido. Weight is going to be the integer 30. So what do? I assign my instance variable. Self.name will equal Fido. Self.weight will equal 30, or will be assigned 30. I know, I always say equal. I have a lot of old 80s and 90s habits that come flying out of my mouth during these videos, and I hope you get it. And I hope I don't misspeak at a time where you're trying to puzzle something out. I know I say equal, but it means assign, because we're doing programming right now. We're assigning values to variables. And that equals is equivalency, and it's 2, and I know I don't want to misspeak. Apologies. So I set my two instance variables, and I'm done. I go to the last line, and I print. I'm going to take my object, myAnimal, and I'm going to run the method getName. So what's myAnimal? MyAnimal is a variable that created an animal object with the animal class. I go to the animal class. Do I have a method called getName? I do. What does it do? It returns the instance variable self.name. Self.name was assigned a line earlier when we gave it Fido. So it should print, as it does right here, Fido. Then you have myAnimal.getWeight. Same thing. What's myAnimal? MyAnimal is an object created with an animal class. So I look up here to the animal class. Do I have a method called getWeight? I do. What does it return? The instance variable weight, self.weight. And what was that set to? 30. So I print 30. Okay? So you can see here we have our constructor that sets the instance variables. And then for each variable, name and weight, I have a getter and a setter, where the getter just returns out the variable, and a setter lets you reset it. Now, some things, like remember our checking account, some things have methods that do the setting. Okay? In this case, just to show you the convention, I did regular getters and setters. Usually, good convention when it comes to creating object-oriented programs. Good programmers will have getters and setters for everything. And this, you may be saying to yourself, well, why do we need a getter and a setter? Why don't I just, just grab the variable and print it out and just say my animal dot whatever the variable name is? You know what? You can do that, but getters and setters are a convention and a vestige of an old setup. Not really an old setup because people still do it. And I don't want to get in the weeds with this. And sometimes I tell this story, sometimes I don't. I guess I'm going to tell it now. When you get involved and start learning about object-oriented programming, there are a bunch of different things that you talk about. You talk about classes. You talk about what we're going to talk about today, inheritance and polymorphism. But there's also another facet called encapsulation. And what that does is talk about how you can create code and the programmer doesn't need to see it. So you can make it private. You can, in C++, there's something called protected. You can, if you want everybody to see the code, you don't really care, you make it public. Okay? By default, everything in Python is public. So technically you wouldn't need getters and setters. You could just print the raw variable, but I usually do getters and setters. Now you may be saying, well, thanks for telling me all that. It's kind of confusing. Don't be confused by it. It's just, if you get involved with Java and C++, you'll know what I'm talking about. There's different levels of security when you create classes. We do everything public and we do everything out in the open, so don't even worry about that kind of stuff. That said, down the line, if it comes up, you'll be like, I never learned that in my Python class. That was crappy. So at least now you know about it, all right? So usually with every instance variable, we do a getter and a setter for it, all right? Even if it doesn't really make sense, because if you have an animal, and if it's a pet, you're going to give it a name. That name rarely changes, but you still have the setter there anyway. So I have getters and setters for name and getters and setters for weight. Weight's reasonable. Dog goes on a diet. I'm sure I went on a diet. Dog gets older, cat gets older, whatever. The weight's going to change, so that's a decent one. And then this guy's going to come into play when we talk about polymorphism. I have a method down there called speak, and right now it just prints sound, but we're going to talk about that later, and you're going to understand what's going on, okay? All right, now, our first topic, inheritance. I want to create a class for a cat. I want to create a cat, and I want my cat to have a name, a weight, and also a color, okay? Now, what do I need to do in order to accomplish this? I'm going to get rid of that code right there. I'm going to make myself some space right here. Do I have to create a whole new class? Well, the answer is yeah, you do have to create a class called cat. But then the answer is, if I'm going to use all of those things I already wrote in animal, do I have to rewrite them again for my class, for my cat class? And the answer to that is no, because we can use something called inheritance. This is best understood if you watch me go. Class cat, but you see up here I had class animal. All right, a little bit of behind the scenes. When I did my checking class in our previous video, there were no parens here, okay? You don't need them. It's a little secret with Python. When you call that class, you call the constructor. And the constructor has parens and takes arguments and does all that. So you don't really need it up there. That said, if you put it there as a placeholder, it's fine. We do need it down here for our class cat because that's how we inherit. I'm going to say cat, but in parentheses, I'm going to say animal. Inherit from animal. So that now when I create my cat class, I'm going to be able to use all of these already written methods. Okay, but there's a price to pay, and I'm going to show you what that price is. I'm going to create the constructor for cat, and what cat's going to take is self, and cat is going to take a name, cat is going to take a weight, and cat is going to take a color. So I'm getting all three of the things that I wanted to grab when I created my new cat. But I got to pay the freight. If I'm going to use animal, I need to create an animal object that cat's going to use. And what I always do at this point, as I talk about, it sounds crazy, but I talk about Mr. Potato Head. You know, Mr. Potato Head is a blank spud, and then you put everything on top of it. Well, when you inherit, think about you just getting that blank spud. Okay? And then you're going to add things on top of it, like with this cat class, we're going to add a new method, and we're going to add an instance variable color. I always do this when I think the answer is yes. I'm a grown man with a Mr. Potato Head in his house. Okay? Because if you are a computer science instructor, it's a good thing to have around when you talk about object orientation. It's like the base spud is the class we're inheriting from, and then all the things you can add to it, be it the nose, the glasses, the everything. That's what we're doing. We're adding on to base functionality. So what I want to do is I want to get an animal object to build on. How do I do that? I run its constructor. Animal dot dunder init dunder. And what do I do? In this case, and you know this usually isn't the case when you create an object, I'm going to throw it self because I want it to know, hey, I'm coming from cat. I'm coming from a class that's inheriting you. So use this. Use self. Use what I just created. Okay? And I'm going to say name. And I'm going to say weight. And that's it. Okay? Because look up here. That's all animal knows. Animal doesn't know anything about color. Color has to be handled like a regular instance variable because that's what it is. It's an instance variable that's new to cat. Okay? So what's going on when I create this cat? I come in here, self, name, weight, color. I take the name and the weight and I throw it up here and I get an animal object. Okay? And then I just add self.color like a regular instance. So this cat object is actually going to have an animal object and a little cat stuff on the side. Okay? Think about it that way. That's the best way to think about inheritance, is that when you inherit from something, you go grab an actual instantiation of that thing, and then you just build on top of it, like you would build on top of Mr. Potato Head and give him a hat, and give him eyes, or give him ears, or do something like that, okay? You're going to get it more when we do that. Now, I've got to do a couple extra things. One, I've added a new instance variable, so I'm going to do getters and setters for it. I'm going to do get color, and all color is going to do is return. We haven't had the discussion about me typing these programs live or me just doing them beforehand and talking about them yet. We'll have that conversation soon, I'm guessing. Return self.color, because some people say it's a bad idea and that I should just do the code and talk about it, but I, for whatever reason, set color. I think it's better for you to see me doing it in person so that I can talk while I'm doing it and kind of like do a think aloud. That's what we call it when, in education studies, when we want people to talk about what they're doing as they're doing it. We call it a think aloud. And if I do a think aloud while I'm doing my code, maybe you can get the idea of what I'm thinking while I'm doing it, and it can help you somewhere along the way. So I kind of like the idea of doing it. Color. I'm taking color here when I do a setter. So, and what am I going to do? I'm going to say self.color is assigned color. And just that easy, we have getters and setters for our new instance variable color. Then there's one last thing I'm going to do, and it's going to come into play when we talk about polymorphism. But right now, I'm going to write a method called speak, and I'm going to print meow, because I know I have a cat. It's in my cat class, right? All right, this is going to make a lot more sense once we play around. Now, and we've finally gotten there, look, we now are so complex that there's absolutely no way we can do what we need to do all on one screen. So congratulations, you've gotten there. I'm going to grab a variable. I'm going to call it cat1, and I am going to create it with the cat class, and I am going to name my cat Felix. And Felix is going to be 50 pounds, and you're going to know about that in a second. And I'm going to make Felix orange in color. Was Felix's cat was black, I think. But we're going to play with that later. Now that I've created Felix, what do I want to do with Felix? I will print, easy, I'm going to print cat1 dot get name. And then I will print cat1 dot get color. All right, so now, if the object-oriented programming gods are with us, I'm going to run this code, and up there on the top, it's going to say Felix space orange. Let's go. And there we go. Felix space orange. Why didn't I capitalize Felix? The OCD will rage if this is not corrected immediately. Felix orange. Okay, so we're in good shape. We are now going to trace through what we just did. Basically, what's going on here? I have a program. It's called animals.py. These comments are ignored. This class animal is put into memory. This class cat is put into memory. This is a comment. Again, the first thing I run is the second to the last line. I create a variable. It's called cat1. I assign it an object. And that object is created with the cat class. And I give it the string Felix, the integer 50, which will be explained in a moment, and the string orange. So, do I have a class called cat? I do. Cat is right here. I go to its constructor. Self, which refers to the memory where that thing, remember the end of the last video. Name is Felix. Weight is 50. Color is orange. What's the first thing I do? I inherit from the animal class, so I'm going to go run that constructor. I use the same self, the location of the current object that I've just instantiated and or created. Name Felix. Weight 50. So I come up here. That object, name Felix, weight 50, and I set the two variables. So that's done. Then I come back down. So now I have an animal object, and I add the color instance variable. So color is orange. Self.color is now equal to the string orange. And then I'm done. And then I come back. So then I go to the second line, and I print cat1.getName. So cat1 is what? It's a variable that holds a cat object, because it was created with the cat class. I go up to the cat class. Do I have a method called getName? Get color, set color, speak. Dun, 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 dun. The answer is no. So Python's about to throw an error, except it'll come back up here and it'll say, does cat inherit from anything? The answer is yes. Cat inherits from animal. So let's go look for it in animal. I come to the animal class. I look for, there's getName. So what do? Return self.name. What was self.name? Well, when we ran the constructor here, we set this instance variable to Felix. So I return Felix to here where the call was, and that's what gets printed. Okay. Now, on the other side of the coin, the second part, cat1, is what? It's a variable that holds an object that was created with the cat class. I look for a method called catColor. Get color. I go to cat. Do I have one? I do. I found it here. So I don't have to worry about anything that I inherited. I don't worry about that because it's right here in my regular class, not my base class, my regular class. Okay? So what does it do? It returns the variable self.color, which we set to orange. So boom, it prints orange. Okay? Now, just like everything else, if I do cat2 and I make it a cat and I call him Joe, and this cat is 40 pounds, and this cat is brown, then I have a whole new object, a whole new kitty cat, and I can print out Joe's stuff just like that. Okay? So you can create as many cats as you want. All right? The last thing we're going to review. Well, actually, before I stop talking about inheritance, I'm just going to let you know from a design standpoint, the reason we do this and the reason programmers like object orientation is because it really emphasizes code reuse. It would be a real pain if I had to rewrite the getters and setters for name and weight, if I had to redo the constructor for cat so that it did everything. Okay? It would be a pain in the butt. The ability to inherit from pre-written classes, and we're just learning. This is a simple class that has a constructor and 5 methods. Most classes have constructors that go half a page, that create 20 instance variables and do a whole bunch of setup work. You'll have sometimes over 100 methods in a class. And if you had to rewrite that for every little instance, like if you had a car class and you had the engine, and you had a certain amount of cylinders, and you had the axles and the wheels and all of this stuff, that stuff is generally the same for all cars, okay? As far as I know, all cars have wheels. All right? Most cars have 4 of them. Most cars have windshields. Most cars have steering wheels. There's some base functionality that's going to be the same for every single example. Well, if I can get that all coded up, and then when I create my Ferrari, I grab the car class and I build on top of it. When I build my Volkswagen, I do the same thing. When I build my, my Jeep, I do the same thing. Okay? That's what design-wise, that's what object orientation is about. It's about code reuse. And if I can define all these base things, and then instead of starting from scratch, when I want to do something special, I just grab the base thing and build on top of it. That's what inheritance is about. And it saves a boatload of time. And you're going to learn moving forward that when you have libraries and you have third-party vendor libraries and you have code that you're going to use, it's going to be full of classes. And what you're going to do is you're going to instantiate those classes, get a real object, and run methods on it. And that's how you're going to do stuff. That's why I've always, I don't know, insisted, because no one ever said no to me, but that's why I always said you have to cover object orientation in this day and age if you're going to do an intro to programming class, which at its heart, that's what this is. Because in the future, you're going to run into it. You're going to run headlong into it the first time you do anything with a library or something like that. Even when we were learning Python, you were using methods and didn't know it. When you use list.append, what do you think that is? Append is a method on the list class. That's all it is at the end of the day. All right? So design-wise, that's what inheritance is all about. It's about using the code. Now, there's a second thing that we're going to go over in this video, and that's something called polymorphism. And basically what I'm going to do is this. I am going to say cat1.speak. And because I do the print in the actual method, all I have to do is say speak. And when I run that, it says meow. Let's trace through that. We already traced through all of that. So cat1.speak. Cat1 is a variable. It has a cat object created with the cat class. So I come to the cat class. Is there a method called speak? Boom, boom, boom. Yes, there is. So I print meow. Okay? And it prints out meow. Now, if I didn't have one called speak, and that didn't exist, so let's zots it out and rerun, then all of a sudden it prints sound. Because, and it probably makes sense given what we just said, cat1.speak. Cat1 holds a cat object. Come up to cat. Does speak exist? No, because I've commented it out. But instead of throwing an error, do we inherit from something? We inherit from animals. So what do? We come up here. Is there a speak method? There is. So I run that speak. Okay? That's really not the point. You may be saying to yourself, oh, okay, it's kind of like inheritance. It looks for it in the cat class, and if it can't find it, you go look in your inherited thing. That's not really the point. The point is this, is that this is generic right here. As a matter of fact, and I do this in other videos, I don't have to print sound. I could just put pass there. Pass is a placeholder that does nothing. If I ran this with nothing here, it throws an error. Because Python doesn't like that. Python wants you to have something there. So you have the pass keyword, which says, you know what, just be a placeholder, do nothing. So now when I run it, I'm back in business. But it doesn't do anything. Because what will happen is cat will look for a speak method. It doesn't find it. It goes to animal. It finds it, but it doesn't do anything. It doesn't even print a blank line. It does nothing. So you get that behavior right down there. What you're going to learn as you move on in your programming careers is that there are some classes, animal might be a pretty good example, that aren't really made to be instantiated. They're made to be inherited. Okay? So you'll get a lot of methods like speak that'll just say speak and then pass. And you may be like, well, that doesn't do anything. What it's telling you is that when you inherit from this, you got to write your own speak. You've got to write your own thing. You see a lot of that in Java with interfaces. It's like, you better write a method called string2 that prints out to this, or you better write your own method that does this, okay? And that's usually what we call, if you have something that's only going to be inherited from it, you call it an abstract class. Little beyond the scope of this course. We're not going to get crazy and get into that kind of stuff. But that's basically what you're doing. So you might be saying, well, polymorphism, why is it called polymorphism? What's going on here? This is the key. And I'm going to go make this guy regular again. Rip the word apart. Polymorphism. Poly means what? Many. Morph while some people might think morph means change, the original connotation of morph back in the ancient days was form. Okay, so the word polymorphism actually means many forms, things that can take many forms. And if you think about what we're doing here, you can have a whole series of classes. Let's stay in our context with animals. Cats, dogs, pigs, cows, horses, whatever. And they all have a method called speak. It's all the same name in every context. The difference being that when you run it on the cat, it says meow. When you run it on the dog, it says woof. When you run it on the pig, it says oink. So you could get into a loop and have 20 objects and say run speak. Okay? You don't have to run a special name for everything. There's only one thing you run, speak. But it does something different for everything, depending on its context. That's the power of polymorphism, and that's what polymorphism is about. I'm going to use the same name, and I'm going to call the same name on 20 different things, and I'm going to get 20 different behaviors, depending on its context. I'm asking a cat to speak. It's going to say meow. Why would it say anything else? I'm going to ask the dog. Dog's going to say bark or woof. Horse is going to whinny. Okay, cow is going to moo. Pig is going to oink. Okay, they're all going to have their own behavior based on the context, but it's the same name. So basically what you're doing with this base class is you're saying, hey, when somebody asks your animal to speak, write a class that makes it speak the right thing. So we did that. Our speak says meow, and when we do it, it says meow. Okay, so think of polymorphism as a method with the same name as all of the other things in that context, but it does your own specific behavior. Okay? And the way different languages implemented in different ways, and this kind of gets in the woods, but what we do in Python is we override functions. So if that function is there and I leave it alone, it'll get run. But what I want to do is I want to override it. I want to have something with the same name in my cat class so it gets run. And we never have to go to the inherited class and see that. So we call that overriding. I want to override that function. In the next video, we're going to talk about overriding some dunder methods. Okay, and do some different things along those lines. But right now, as far as simple polymorphism, we just want to override that speak so our new object says what we want it to say. All right? So, Whirlwind Tour, that's inheritance, and that's polymorphism. Okay? I'm going to take this code, maybe not now, maybe after I do the second video, because you'll see after the second video, we're going to build on this. We're going to add a dog class, and we're going to do some extra special things. And then I'm going to take all of that code, and I'm going to throw it up. So you don't have to take this and play around with it yet. Wait for the next video, which hopefully today is Easter Sunday. The Mets have already ruined Easter. Well, I think they did. It was the 7th inning, and they were losing 4-1. Hopefully in the next couple days, I'm going to Boston, so I want to get that third video done before I leave. So maybe tomorrow night, but tomorrow night's tough because Michigan's playing Villanova, and Tuesday night's going to be tough because it's the night before I leave and blah, blah, blah. But I got to get you that video, and I'm going to get you that video. I wouldn't be surprised if I shoot it in a hotel room in Boston on Wednesday night. That could be the case. Anyway, check this video out. Don't type up the code. You can type up the code if you want. It's always a good idea. Like learn Python the hard way. If you type things up, then do it yourself. That's great because then you make mistakes and you have to correct those mistakes. And if you can correct those mistakes, it means you understand it. So that's always a good thing. But I'll get this code up on Sakai eventually. Maybe I just will throw this up. I don't know. I don't want to get confused because we're going to build on it later and you're going to have a bigger, better version after video 3. So maybe we do that. All right. Like yesterday, I'm going light on announcements. The only thing I am going to say is today is April 1st, April Fool's Day. In 6 days, your proposal is due. The second thing I will say is that I'm working on your midterm papers. I'm trying to get them done 2, 3 at a time whenever I have a spare moment. I got to read and comment and do a whole bunch of things on like 30-something of them, so it's a lot of stuff. I'm working on it. I'm getting there. You're going to get your midterm grade very soon, definitely before the end of Unit 5. But hopefully, maybe the beginning of next week, I'm going to start returning those, all right? So that's on the radar. I am also going to get examples up, probably later tonight, of decent proposals from the past that I've used. So don't worry about that. That's coming. All right? All right, then I'm going to get out of here. You be good, and keep your eye out for that third review video, because once I do the third review video, then I'll put up the assignments, and you'll be able to mull over the assignment. Okay? Because when this assignment, I don't want to freak you out, but when you get this assignment, you're going to be like, huh? Because it forces you to think more than it forces you to code a ton. All right? And you'll see what I'm talking about when you get it. I don't want to freak you out. All right, you be good. Happy Easter if that's what you celebrate. And I'll be getting back to you soon with video number 3. All right? Talk to you soon. Bye.